Alright, we're dealing with the real number system. The essential questions is what are ways to engage and express knowledge of real numbers? What we want to talk about here is all the different subsets of the number system. And as we can see here, we have the natural numbers, the whole numbers, integers, rational numbers, and then out here you have the irrational numbers. I want to take a second and just talk about what are each of these numbers. Well, if you look at the natural numbers are they're just going to be their counting numbers. The natural numbers they will start at 1 and go up from there. Natural numbers do not include 0. So, for example, here I'm going to change color here. I'm going to say 1, 2, 3, and on from there. Those are all the natural numbers. From there, I go to my whole numbers. Well, whole numbers are all the same numbers except it adds in 0. So I have 0, 1, 2, 3, and I'm going to put the dot there. And as you can see, whole numbers and natural numbers go together except for the zeros. In other words, all natural numbers are also going to be whole numbers. Well, if we go up one more step to integers, well, not only do integers include 0, 1, 2, and 3, so not only do they include all of your natural numbers and all of your whole numbers, they're going to include negatives as well. So I could say -4, -3, -2, -1, 0, 1, 2, and on from there. And that falls under the integers. Now, if you notice, so far we haven't dealt with any fractions or any decimals up to this point. So now, as I move up to rational, well, rational numbers do include all integers, all whole numbers, and all natural numbers, except there's some fractions and decimals included. For example, here I have 1/4. Well, in the decimal form is 0.25. Well, one of the ways that is rational is rational numbers include decimals that are either terminating, which means they stop, or they have a repeating pattern that goes on and on. For example, I may have 0.323232, and it goes on and on. Or I could say 0.3333. It's a repeating pattern that goes on and on, which again, it includes all integers, all whole numbers, and all natural numbers, including decimals that terminate or they have a repeating pattern that goes on and on. And that just leaves irrational, which is kind of out there. If you notice, it's not connected to any of these, because if it is rational, it cannot be irrational as well. So for example here, irrational, if I have, I'm going to say the square root of 3, and if I do that, the square root of 3, I'm going to get the number that comes up would be 1.73205808 which means this goes on and on and on. If you notice, the decimal does not terminate, and there's no repeating pattern of the number. So in order for it to be irrational, it goes on and on without a pattern from the decimal. So now let's look back over here and compare the two. Rational, it terminates or it has repeating pattern. Irrational, it goes on and no repeating pattern. So if it terminates, it's going to be rational. And the way I can look at this on when I'm looking at different numbers, if it has the ... that tells me that it goes on and on and on. And then I just want to look for my repeating pattern. If no pattern, it's going to be irrational. So let's look at a few of these. Again, we just looked at this, but I go back, the square root of 3, I pick that, and I get this decimal. So here, what all number subsets does this belong to? I want you to go ahead and if you have pencil paper right there, which you should, write down what all does that fit under. Again, like I said before, The only one this could fit under would be irrational. And if it's irrational, that means it can't fit under any of the other subsets. Let's go to the next one. Okay, now here I have negative 52.28. Well, pause this video for a second, take a second, and write down what subsets does this number belong to. Well, as we look back here, you're going to have actually, let's look back at our thing, negative 52.28. I'm going to write down here, negative 52.28. Well, if I look, it can't be natural, because it's a decimal. It can't be whole, still a decimal, and it's negative. Integers are negative, but they do not include decimals. So I have to look and say, is it either rational or irrational? Well, I look at the characteristics of rational. Rational numbers have a repeating pattern. They go on, or they terminate. Well, when I look back at negative 52.28, I notice this stops. So that tells me that it fits under the rational subset. And that's the only one other than real number. And I think all that we're going to deal with, every one of those are included as a real number. Now, if you look here, you may get something like this. And here's the tricky part. If I just put this in my calculator as negative 16, or not negative 16, if I put the square root of 16 divided by 4, it gives me 2. That's the danger of using a calculator on everything you do, because the truth is the calculator doesn't understand the order of operations. Because if I look at this, I see, okay, I need to take the square root first. I need to take the square root of 16, which is 4, divide that by 4, and really the answer should be 1. Well, 1 fits under several subsets. Let's go back over here. 1 is included as a natural number. 1 is also included as a whole number. It's an integer, and it's also rational, because if it fits under any of these categories, you know it's going to be rational. So those are the ones it fits under. So we can say natural, whole, integer, and rational. Now let's take a look at this one. You have the square root of 35. Well, I can do this a couple different ways. I can, if I want to, I can say the square root of 35, and I'm going to get this decimal. Actually, before I go on, I want you to pause it and actually, and you can use a calculator for this one, and come up with the decimal. When you do that, you get 5.9160,797,83 ... It goes on and on. And there's only one category that this one can fit in, and that is obviously going to be your irrational. And if it's irrational, what makes it irrational? I want you to tell somebody or talk to yourself, however, what makes this irrational? I'm going to give you a second to kind of define it to yourself. All right, what makes this irrational is it goes, the decimal, it goes on and on, it's non-terminating, and there is absolutely no repeating pattern to this. Alright, if you look at this, 5/8. 5 divided by 8, and you come up with 0.625. Now, if you have a calculator, you can just say 5 divided by 8, and it'll give you the decimal. Well, when you do that, what all subsets does this belong to? Take a second, write this down before I go on. Alright, as you've written it down, if you notice the characteristics of it, okay, it's a decimal, so that tells you it can't be natural, can't be whole, can't be an integer, so that must mean it can only be either rational or irrational. Well, let's look at the characteristics. Irrational numbers. Well, if they're a decimal, they go on and on and on. No repeating pattern. Well, you notice there's no dot, dot, dot. It just stops. So if it stops here, that means it terminates. Well, the characteristics of a rational number is either a repeating pattern that goes on or it terminates. So 5/8, you're going to notice, is rational. Alright, if I just give you the number 3, I want you to go ahead and list. I'm going to pause for a second, and you can pause the video. Go ahead and list the subsets that the number 3 belongs to. Okay, so as we look at 3, let's see, what are natural numbers? Well, they're your counting numbers, which means they start with 1. So you know natural. Whole numbers, again, counting numbers except they start with 0, so it can be whole. It's an integer. And it's going to be rational. If it's any of these, it has to be rational. Let's move on to here. Okay, here's another one, kind of like one we had earlier. I want you to go ahead and try this one before you actually listen to the instructions on it and see what we come up with. See if what you get matches what I get. So pause the video and do this one. Alright, as you look at this, again, if you just put it straight in the calculator, you're probably going to come up with the wrong answer, right? Because you're going to come up with a different number. But if I look at my order of operations, the square root of 81, well, what can I multiply by itself to get 81? I'm going to get 9. That's a perfect square over 3. Well, then I divide 9 divided by 3, which equals 3. Again, I'm just going to use the letters. It fits under natural, whole, it's an integer, and it's going to be rational. Alright, here's a question. Error or not, did the student make a mistake? A student said that all integers are whole numbers. Well, what mistake did this student make? I want you to write down what mistake do you think this student made? They said all integers are whole numbers. Alright, my question is this. What do integers include? Integers include negatives. Oh, let me change the color. They include negative numbers and positive numbers. Whole numbers, they start at 0. So in this case, the mistake the student made was integers include negatives, whereas whole numbers do not include negatives. And let's look here, and as we've done this, I do want to look at one other thing here, and I think is when you look at the square root, in order to be able to tell if a number is rational or irrational, I can say this. If it is a perfect square, in other words, like the 81 we talked about, well, you have 9, and you know that's going to be a rational number. If it's not a perfect square, I am yet to see an incident where it is not irrational. So in other words, do you even need a calculator for this one? Is there anything you can multiply by itself to get 15? Well, that's a rational or whole number, and the answer to that is no. So I know that it's going to be irrational. And to test this, when I take the square root of 15, I get 3.87298334 dot dot dot. Again, irrational, no repeating pattern, and it's non-terminating. Alright, and this is an interesting one here. How do I know if this number is irrational Well, if you try to divide 3 over 0, um, even if you use a calculator, however you want to use it, you're going to get an error because this cannot happen. It is going to be undefined. Well, actually, a better term for that is non-real number. That would be a better term for that number. And you'll learn more about non-real numbers later, but you can't divide anything over 0. Now, if I flip that around, so 0 divided by 3, I would get 0. But I can't divide anything by 0. 3 divided by 0, non-real number. Alright, what I want you to do is I want you to, your last challenge, go back through some of these questions that we've worked through, and you're to use a think, pair, share to someone at your house. And what they are to do is send me a sheet of paper signed saying that you have actually explained the problem to them, explained the process, not just the answer, but told them, for example, if you choose 5/8, you are to explain why is that rational, not just that it's rational, but why. Um, I would love actually for you to choose, let's go 2 of them, because that way you can choose, let's say, a decimal, and then choose one that fits all of them. But why is it a natural number? Why is 3 a whole number? What makes it that way? Because you hear this a lot in my class. If you can explain it, you've got it. So you need to make sure you bring in something signed from a parent, someone at your house saying you have explained the process to them. And I will see you in class tomorrow.